This is chapter 32, phase diagrams for micellar systems. To introduce complex fluids, these include micelles, colloids, gels, networks, and so on, self-assembling systems. Basics of micellar systems. Micellar systems consist of mixtures of water, oil, and a surfactant. The phase diagram of the ternary micellar system, in other words, water, oil, and surfactant, is represented by a triangle, ABC triangle, with 3 corners. There are 3 binary systems like AB, AC, and BC. These contain a mixed phase or one phase region and phase separator or 2 phase regions. Like for example, the oil surfactant system, the oil surfactant system is a upper critical solution temperature, UCST. In other words, if we cool down, phase separator is 2 phase region, 1 phase region at high temperature. The water oil system is also a UCST, 2 phase system at low temperature, but contains a closed loop immiscibility island also. 2 phase, 1 phase, 2 phase, 1 phase. That's the water surfactant region diagram, AC. Whereas the let's say the water oil system is always in the 2 phase region. Water and oil do not mix. So this is almost like the schematics of the ternary phase diagram, of the 3 binary phase diagrams. Let's go look into the ternary phase diagram now. First, let's say something about phase separation, which proceeds along tie lines. Like for example, the water surfactant system, UCST, this is upper critical. This is a critical point. This is spinal region. This is also another spinal region, closed loop. So if we jump from the 1 phase to the 2 phase, phase separation proceeds along this tie line in such a way that we get a phase rich in surfactant and another phase rich in water. Same thing here. We get this composition rich in surfactant and another one rich in water. So phase separation always proceeds along tie line. This is temperature rich composition. Phase diagram for the ternary mixture, the ABC triangle. We get the micelle formation phase as well as the 2 phase regions. Let's look at it here. There's a 2 phase region. There's a micelle phase region. The critical point now is called the plate point, and these are the tie lines for phase separation. Surfactant, water, oil. When the closed loop region is reached, there's an interplay of interactions. We might get a 3 phase region. In other words, in the phase diagram there is 1 phase region for the lower part of the phase diagram, UCST, and we might get a second 2 phase region here due to the closed loop for surfactant water. So sometime when the interactions of the surfactant are very strong, it's either strongly hydrophobic or strongly hydrophilic, we can get a 3 phase region, which is the overlap of the 2 phase regions. So let's look at the critical points line. First, without the closed loop, this is the UCST for surfactant water. So this plate points line, critical points line, varies like this. This is temperature. When the surfactant becomes more amphiphilic, the closed loop appears, and we get a second branch here, high temperature. In other words, temperature versus oil water phase, something like this. Let's look at when the 3 phase region shows up. So we have this phase diagram here. When the surfactant becomes more and more amphiphilic, we could get a tricritical point here, and then formation of a three-phase region. There it is, a case where we have a three-phase region that forms. So high temperature here, we got a two-phase region where the surfactant mixed with oil, and there's water at the bottom, not a lot of surfactant. Low temperature, surfactant mixed with water, and oil at top, not much surfactant and oil. An intermediate region where we have water, a surfactant phase, and an oil phase. That's the three-phase region. This is a two-phase region, high temperature, two-phase region at low temperature. This is actually called the prism phase diagram. It looks like a prism. The surfactant is transferred continuously from the water-rich phase to the oil-rich phase as temperature increases. So there you go. That's the three-phase region. If we have a very strong amphiphile surfactant, a weak amphiphile. So if we take a cut MC along this ternary phase diagram, we get what is called the fish phase diagram, because it looks like a fish. There's temperature, we're increasing surfactant fraction, so we're moving along this MC phase line here. So first we get two-phase region at low temperature as well as high temperature, where surfactant here is in water, here surfactant is in oil. We get the three-phase region here, and then high surfactant fraction, we get the M phase, the micelle phase, very rich phase here, where you have oil in water structures, spherical, cylindrical, lamellar, or water in oil structures, spherical, cylindrical, lamellar, where the surfactant is forming the interface. This is very rich micellar phase. The M phase, the micellar phase, is the focus of SANS investigations. There's all of these mesophases phases like lamellar, micelle, spherical, cylindrical. There's also the so-called microemulsion phase. It's also called bicontinuous phase. The micelle formation phase is obtained with either ionic micelles, ionic surfactants, or non-ionic surfactants. This is the case where we're using pruronic P85, which is a triblock copolymer, no charges, so non-ionic surfactant. It's PEO, PPO, PEO in deuterated water. We do SANS. So we find that above a certain temperature, called critical micelle temperature, micelles form. This is micelles here and unimers here. In other words, dissolved triblock copolymers here. This is above a certain temperature and above a certain concentration, like critical micelle concentration. And that was for 1% P85 in D water. Let's look at the intensity versus Q for that 1% P85 in water, and we vary temperature. This is the unimer phase, triblock copolymer dissolved in water. We increase temperature, we get spherical micelles are formed. If we increase further, we get cylindrical micelles formed, like for example 70 degrees. The transition from the unimer region to the spherical region, then to the cylindrical region, can be better observed if we take intensity at a low Q here versus temperature. If we took a low Q value, intensity versus temperature, so we really see the unimer phase, spherical micelle phase, onto the cylindrical micelle phase. Upon heating, upon cooling, not much change, so these transitions are reversible. Actually, the P85 pruronic in D water phase diagram has been mapped out using SANS as well as other techniques. We see the 1% here and the 10% here. There's the unimer phase, the spherical phase, the cylindrical phase, the lamellar phase. There are other phases at high P85 fraction, I think hexagonal phase, cubic phase, lamellar phase, and so on. here just including typical surfactants like CTAV, SDS, AOT, and as well as scattering densities for water and decaying, just to compare. So these complex fluids could be referred to as self-assembling systems. In other words, they self-assemble to form micelles or other structures. These are the main references: Galwait and Stry for the phase diagram, and Mortensen for the P85 phase diagram. Let's go over a couple of questions and answers. What is a tie line? A tie line is the line in the temperature concentration phase diagram along which phase separation proceeds. Question 6. Define the two-phase region for ternary water-oil surfactant system. The answer is this ternary system consists of a mixture of two phases, one rich in water and one rich in oil. Question 7. What is referred to as the fish phase diagram? Actually, this is question 9. The fish phase diagram maps out the two-phase, the three-phase, and the M-phase regions in the temperature surfactant concentration plot. Question 10. What is the prism phase diagram? We saw this. The prism phase diagram is the extension of the ABC triangle phase diagram to 3D by adding the temperature variable out of the page. Question 12. In which part of the phase diagram is the SANS technique most effective for ternary system, and why? Answer: the SANS technique is most effective in the micelle formation phase, since micelles are of nanometer sizes. The two-phase and the three-phase regions are characterized by huge micrometer scale or larger droplets. It's more like light scattering window.